All right. So one thing I noticed once we were doing this question, I had changed the numbers to do this question so that we could get good, so we wouldn't get something like I'm going to get when I solve this. Where was I solving that? I might have deleted mine. Anyway, we were working on this right before lunch, and I switched numbers around so that we would get whole numbers for our y-intercepts so that they'd be easier to solve. And to do that, I changed the numbers on my key, but not on here. What we have to do is change this 8 and this 3. Okay, so we're going to switch these numbers just so that we get easier numbers to solve. So that means this is going to become 3x and this is going to become 8y. Sorry about that. But in that way then, this is going to be an 8y and this is going to be a 3x. So basically we just switch this 8 and 3. And like I said, it's just the way you set up the problem. And I didn't switch it in my thing. So let me try to delete my note. And then I also had graphed the x equals and y equals, so, and I deleted that. So let me do that really quick. And then we were solving, right before lunch, we were solving this equation for y. Okay, and so what we would do, we're just going to get better numbers to work with. This would be 8y is less than or equal to negative 4x plus 32. And when we divide by 8, we won't get a mixed number or a decimal. So that's why I switched that. Okay, so when you solve, did you guys get this then? And we're going to graph this. Okay, so let's go up to 4. And our slope is negative 1 over 2, so that's down 1 over 2. Which is the same as up 1, left 2. Okay, and this one is less than, so it's going to be below. Less than is always below. Okay, and then I also need to take this equation here and solve it for y. So I'm going to move that up here. 3x plus 2y is less than or equal to 12, and I'm going to subtract it for, solve it for y. When I move that 3x over, I'm going to subtract 3x, and I get negative 3x plus 12, divide by 2, and y is less than or equal to negative 3/2 x plus 6. Okay, so now what we're going to do is go up to 6, go down 3 over 2, down 3 over 2, down 3 over 2, and again it's a solid line. And then draw a straight line through there. Okay, and again this one is less than, so it's going to be below. So if you guys look here, we are above this, to the right of this, and we're below both of these lines. So do you guys see it's this little spot here? Okay. So it's going to be in here. All right. And then we have to find those points, our vertices. This one is 0 up 4, so that's the vertices 0, 4. This one right here is over 2 up 3. This one, 1, 2, 3, 4, so 4, 0. And then this vertice right here is 0, 0. Are those the ones you guys got? Okay. So I'm going to go down and write those down. 0, 4, 4, or 0, 0, 4, 0, and again in any order. Doesn't matter how you write these down. And in this one, what we did is we just want to know how many maximum number of gallons can he mix. So our function here was just x plus y. So all we have to do is add. So in this case, it's just 4. 0 plus 0 is 0. 4 plus 0 is 4. 2 plus 3 is 5. Our maximum amount that we can make with that dye is 5 gallons. Okay. Now, I think what I'm going to do is just do this one with you guys, and then I'm not going to give a word problem in your assignment. You'll just have the other kind in your assignment, okay? This one here is talking about mixing 2 types of food, brand X and Y, for his cattle. Every serving is required to have 120 grams of protein. So in all, we want a serving total to have 120 grams of protein and 30 grams of fat. Okay. It says brand X has this much protein, this much fat, and costs that. So we're going to let X equal the number of units, or units of brand X. And we're going to let Y be the number of units of brand Y. Okay, so what we have here is the 20 grams of protein for X. So here's our brand X. Now this one's a little bit different because we're going across. X is going across here, and it's 20 for protein for X, so that's 20X. 20 grams of protein for every unit of brand X, so it'd be 20 times X. Then it's 10 grams of fat. So I'm going to go over to this fat one, and we're still in X, so it's 10 times X for fat. Okay, so it's 20 grams of protein in every unit of brand X for protein, and it's 10 grams in every unit of X for fat. And then it costs us 80 cents. So I'm going to write that as 0.8 for every unit of X that we buy. And so that would be times X. Okay. The next one is for brand Y, and brand Y is 40 grams of protein. So that's 40 times every unit of Y, and then 5 grams of fat per serving. So that would be 5 times Y. And then that one costs 50 cents. So that's, we're going to write as 0.5 Y. Okay. In this one, they want the minimum cost. So here's what we're going to do. Our cost is going to be 0.8 or 0.80, however you want to write that, plus 0.5 Y. So we're going to graph those, try to find it, and then go from there. So in all of these, when it's a word problem like this, your x is going to have to be greater than or equal to 0, and your y is going to, because we can't have a negative amount of a gram, okay? Now for the protein, we're going to go down, okay, because our total is down here on this table. So it would be 20x plus 40y. And in this one, their diet is required to have 120 grams. That's the minimum. They could have more protein, they just can't have less. So that means that has to be greater than or equal to 120. It has to have 120. It could have more than that, it just can't have less than that. And then for the fat, they tell us it has to be 30 grams. It could be more than that, but it can't be less. So it'd be 10x plus 5y has to be greater than or equal to 30. And we're going to graph this and find our vertices. So the x equals, or the x is greater than and the y is greater than, those are just these two lines, ensuring that we're going to get shaded in the first quadrant because these are word problems. Okay. Then I'm going to take this. Actually, let's do this one first because this one's listed here. Let's solve this last one for y. So we'd get 5y is greater than or equal to negative 10x plus 30. Okay, we're going to divide by 5. And y is greater than or equal to negative 10x divided by 5 is going to be negative 2x. And then 30 divided by 5 is 6. So let's go ahead and graph that. 1, 2, 3, 4, 5, 6. And we're going to go down 2 over 1. Okay, and this one is greater than. So this one's going to be a little bit different. We're going greater than for this one. Now the other one, if I take that 20x plus 40y is greater than or equal to 120, and I subtract my 20x, I get 40y is greater than or equal to negative 20x plus 120. Now we're going to divide by 40 on each, and we get y is greater than or equal to negative 1/2 x plus 120 over 40 is 3. Okay, so I'm going to go up to 3, and then it's down 1 over 2. Which is the same as up 1, left 2. Okay, now in this one, 2, it's a greater than, so we're above. So when we were doing these today, we usually had an enclosed spot. That's called bounded. This one is actually going to be unbounded, okay? Because we need to be above the blue, above the purple, to the right of the green, and above the pink, okay? Do you guys see where that would be? It's going to be bounded by these 3 points, and it has to be above the purple and above the pink, so it's all of this up here. So it has to be to the right of the green, above the pink, above the blue, above the purple, and that ends up being right there. Okay? So this one's called unbounded. Okay? This vertice right there is 0, 1, 2, 3, 4, 5, 6. This one is over 2 up 2, so 2, 2. And this one here is over 1, 2, 3, 4, 5, 6, comma 0. Is that what you guys got too? Okay. Now, I can go down and copy my cost formula down here. 0.8x plus 5y, 0.5y, sorry. And our vertices are 0, 6, 2, 2, and 6, 0. So this one would be 0.8 times 0, which is just 0, plus 6 times 0.5, which I believe is just 3. I don't know where I put my notes, but if you guys plug that in, 0.8 times 2 is going to be 1.6, plus 0.5 times 2 is going to be 1. Did you get that to be 2.6? $2.60. And then 0.8 times 6 plus 0.5 times 0 is, I believe, going to be 4.8. And these are dollars, so it's like $4.80, $2.60, or $3. Did anyone punch those in? Did I do that right in my head? Okay. We want, if we look back at the problem, he wants to minimize his cost. Okay? This is the cost of those 3 options. We want the minimum one. So what did we pick? The $2.60, right? Now, I don't think you guys are going to be heartbroken about this, but I didn't really like any of the word problems that were in the book because none of them had like good intersecting points. So I was going to do this last one with you, but I'm not going to make you do this problem. And here's what we're going to do. You are going to do these 5 problems. Or gosh, I thought I took one of those off. Let me look in the book super quick. There's my book. You know what? Just do 3, 5, 11, 17. You know what? It seems like. Oh. I tell you what. Let me just make sure I didn't do number 1 in class. Because I almost think I did. Hold on 1 second. Okay, here's what we're going to do. We are going to, I'm sorry for changing this again. We are going to do number 1, but skip number 20. So you're going to do these 5. Okay? Sorry for the confusion. And so you really didn't need this one piece of paper because that was for that word problem, but just keep it in case you need it sometime in the future. And yeah, sorry it took so long today. And then Monday we're finishing the chapter, and Tuesday we're doing a practice test. Wednesday is your test, okay? Just so you kind of have that plan.